Hey everyone, welcome back to AI Terms. Today we're talking about something that powers almost every AI system you've ever used, vector embeddings. It sounds technical, but by the end of this video, you'll see it's actually a really simple idea, and a pretty magical one too. Let's dive in. So here's the problem. On one side, you have a human brain. When I say the word dog, you immediately understand what a dog is. You know a puppy is basically a baby dog. You know a dog and a cat are kind of related, both pets, both animals. And you know a dog has nothing to do with a television. That's obvious to you. But on the other side, you have a computer. A computer doesn't understand anything. It just sees ones and zeros. It doesn't know what dog means. It doesn't know what puppy means. For a computer, every word is just a random label. So the question is, how do we make a machine understand that dog and puppy are related, but dog and TV are not? That's where vector embeddings come in. A vector embedding is just a list of numbers. That's it. A long row of numbers that represents something, a word, a sentence, an image, any piece of data. Here's what the embedding for dog might look like: 0.12, minus 0.84, 0.53, 0.97, minus 0.31, sometimes hundreds of numbers long. Now, numbers on their own aren't very useful. But here's the trick: you can think of these numbers as coordinates on a map. Just like how every location on Earth has a latitude and longitude, every word has a coordinate in embedding space. And here's the beautiful part: similar things end up close together. If you plot the embeddings of words on this map, you'll see dog and puppy and hound all clustered together in one region. Cat is nearby too because they're all animals. But TV and phone? Those are way over on the other side of the map, in a completely different neighborhood, electronics. So an embedding is just a list of numbers that acts like a coordinate. Similar things, similar numbers, close together on the map. Now here's where it gets really mind-blowing. Because these are just numbers, you can do math with meaning. There's a famous example. If you take the vector for king, subtract the vector for man, add the vector for woman, you get the vector for queen. Think about that for a second. The computer never learned a dictionary. Nobody told it that a king is the male ruler of a kingdom and a queen is the female ruler. It figured out that relationship just by reading patterns in text. King minus man plus woman equals queen. That's not memorization. That's understanding. So how are these embeddings actually created? It's surprisingly simple. You take a massive amount of text, billions of sentences, and you train a model with a very basic rule: words that appear in similar contexts should have similar embeddings. Imagine a window sliding across a sentence. The cat sat on the mat. The model looks at pairs of words that appear near each other, the and cat, cat and sat and on, and it slowly learns that cat and mat are words that share a context. No dictionary. No grammar rules. Just patterns. Just vibes from data. Okay, but why should you actually care about this? Because embeddings are running behind the scenes in almost every AI tool you use today. First, semantic search. Type cheap hotels near the beach and it finds results that match what you meant, not just the exact words. That's embeddings. Second, ChatGPT's memory. It uses RAG, takes your question, converts it to an embedding, looks up facts by meaning, then answers. Third, recommendations. Netflix, Amazon, Spotify, every recommendation engine uses embeddings. You liked Inception? Here are similar movies in the same neighborhood. So let's tie it all together. We started with a problem: computers can't understand meaning. And we ended with a solution: a list of numbers that captures what things mean. Embeddings are the bridge between human meaning and machine numbers. They're why AI can understand intent, not just match keywords. Simple numbers. Simple idea. And it powers everything. If this was helpful, Hit subscribe for more AI terms. I'm Vimal, thanks for watching.